So solids are those substances which have definite shape and volume. Okay. Basically, I used to define with the rigidity. Means they are rigid. Okay. So you can say solids are rigid. Rigid means, what does the rigid means? Rigid means they are resistant to change their shape. Okay. Why this is so? ऐसा क्यों करते हैं? Why this is so? They are resistant to change their shape because the intermolecular attraction force between the solids is very strong. Okay, the solid particles are held so strongly with a strong intermolecular force of attraction, so they are not able to change their position. So this is the reason why they are rigid. They cannot change their shape. The intermolecular attraction force in liquids as well as in gases is weaker, so the particle can move from their position. But in case of solids, the particles are imposed, okay, to change their position, to not change their position. The particles have fixed position in case of solids, so they are rigid. They cannot change their shape. Basically, solids are of two types. Okay. First kind of solids are crystalline. Crystalline solids. What crystalline solids are? Those solids in which the position of particle or the shape formed by the particles within the solid is fixed. Okay. If the particles do not have any kind of pattern for the packing, then they are amorphous. 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 The literally amorphous means no shape. Okay. Literal meaning of amorphous is no shape. It's the particles do not form any shape. Here, the particles are there in a square form. So you can say this is a crystalline solid. Suppose if the particles are not forming any shape and they are arranged randomly, so it is a solid and you can categorize this solid as amorphous. Okay, so there is no pattern of packing. If you join their centers, you will find that they are not forming a particular shape. Okay, so what you are finding, there is what? Triangle, there is a square, there is a triangle, again there is, as means the pattern is not fixed here. Okay, so this is, you can say, amorphous, and you can say this is a crystalline. This is a crystalline. And this is what? Amorphous. Amorphous. For the exam point of view, if you have to study the crystalline and amorphous solids, you have to differentiate them. Okay, on the basis of their characteristics, you have to differentiate them. So first of all, we are going to study crystalline solids. Okay, crystalline solid. Crystalline solids. So from the previous discussion, we know that what are crystalline solids? Crystalline solids have fixed pattern of particles. Like this solid. Okay, 1 2 1 2 3 1 2 3 1 2 again 1 2 3. So you will find a fixed pattern of particles. Okay, they are forming a hexagon. So you can say this is a HCP, hexagonal close packing. And this kind of hexagon you will find throughout the solid. They are crystalline. Okay, they are crystalline. So about crystalline solids, we can say they have definite pattern of packing. Yes, that's true. Second thing, they give clean cleavage. Clean cleavage. What does the clean cleavage means? What does the clean cleavage mean? Just suppose you have a crystalline solid, okay, and you have to split it in two parts or more than two parts. If you split the crystalline solid and the surface developed after splitting is smooth, then you can say it is clean cleavage. Okay, why does it happens? Why does it happens? You know very well, crystalline solids have well arranged particles. Okay, so suppose these are the two rows of the particles, and you are trying to split it from here on. You are trying to split it from here on. You have put a sharp edge tool here. Okay, you have put the sharp edge tool here. What you will find after putting the sharp edge tool, the two rows of the particles get separated. These two rows of the particles get separated, and you will find the new rows, okay, you will find the new rows, they get separated, and the new rows have smoother surface because of the well arrangement of particles. Smoother surface because of well arrangement of particles. Okay, this surface which is developed after the splitting is smooth because the particles are well arranged here. I hope it is clear to you. Second thing, first they have definite pattern of particles. Second thing, they give clean cleavage, and the third one, their melting point is fixed, or you can say sharp. Okay, sharp means suppose you have a solid, okay, and its melting point is 927.23 Kelvin. Okay, suppose you have a solid X solids, this is X solid, okay, and its melting point is 927.23 Kelvin. So this remains solid up to 927.22 Kelvin. It is solid. Up to this temperature it is solid, and as soon as you will find 927.23 Kelvin temperature, it becomes liquid. Okay, so within a moment it changes to liquid. Okay, this is what sharp melting point. So Crystalline solids have sharp melting point, and the reason is simple, very simple reason. Uh, there is a definite arrangement of particles. And the next one is they are anisotropic. They are anisotropic. What does the anisotropy mean? This is important thing to know. Suppose if you observe some physical property like electrical conductivity, refractive index from the different angle of the solid, it will give you different value. So we'll discuss the anisotropy now. Anisotropy. Okay. Suppose this is the solid we have. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, like that. Suppose if you observe this solid from this angle, okay, from this angle, you will find a continuity between the particles. Okay, this is the arrangement. 1, 2, 3. 1, 2, 3. Okay, if you observe the same solid from a different angle, suppose the angle is right angle, okay, then you will find 1, 2, 1 skip, there is a skip, okay, then 2. Okay, if you observe the same solid from this angle, okay, this is again right angle with respect to the angle I have drawn earlier, so you will find there is no particle, clean space. Okay, so light can pass out easily. Light can reflect from this particle. Light can pass through here. So if you change the angle in case of crystalline solid, you will find a different magnitude of some properties. Okay, so we say the crystalline solids are anisotropic. We used to say the crystalline solids are anisotropic. Okay, and the reason is the different framework of the particles, you can say, which is observed from different angles. If you observe the crystalline solid, the framework of the particle, the arrangement of the particle will be different. Okay, from every angle, by changing the angle, if you observe this particle from here, it will have a different arrangement. From this angle, it will have different arrangement. Okay, so by changing the angle, you will find the different arrangement of particles, and this property is called anisotropy. So how you will define the anisotropy? If you change the angle, the different magnitude of some properties from different angle. Different magnitude of some properties from different angle is called anisotropy. Okay, so crystalline solids are anisotropic. Okay, they have long range order. The next one, they have long range order. Long range order. So what they have? They have long range order. What does the long range order mean? Okay, let's see an example first. This is a crystalline solid again. I'm drawing a crystalline solid. Particles are regularly arranged. Okay, so we are focusing what? Long range order. Okay, this is a smaller region of the particle, a small region. Okay, what this arrangement is, you will find the same arrangement throughout the solid. Okay, you will find the same arrangement of particle throughout the solid. This is what? Long range order. Long range order means the arrangement of particle which exists in a smaller region is repeated throughout the solid is long range order. Okay, they have long range order means the arrangement, the fixed arrangement, the definite arrangement which exists in a smaller region of the solid, it is found throughout the solid. This is the reason that they have sharp melting point. Okay, this is the reason they have sharp melting point. See, suppose this region melt at 927.23 Kelvin. Okay, this region, this particular region, what I am referring is melting at this particular angle, particular temperature. Okay, P. So all the region P, Q, R, S, T, U, V, W, X, all the regions will melt at this temperature. Okay, this is what? Long range order. All the regions which exist throughout the solid are similar. This is what? Long range order. So now we are focusing on next, amorphous solid. Amorphous solid. What are amorphous solids? Already we have discussed, they don't have any arrangement of particles. Okay, their particles do not have any fixed pattern of packing. Okay, amorphous solids do not have any fixed pattern of packing. See, like this, 1, 2, 3, 4. Okay, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Like this. Okay, 1, 2, 3. 1, 2, 3, 4, 5, 6. Like that. So here you will find smaller regions. Okay, smaller fixed packing regions. Okay, this is a fixed packing region, this is a fixed packing region. Okay, but they are different. They are not same, they are different. Okay, if they are same, it becomes a crystalline solid. If they are different, they are amorphous solid. Okay, like this. So here every region has its own packing. Okay, in case of amorphous solid, every region has a different packing. Okay, so they don't have any fixed pattern of packing throughout the solids. Every region has a different packing of particles. Again, you can say they don't give clean cleavage, they give rough cleavage. They give rough cleavage. Rough cleavage means if you try to cut the solid, the surface developed is not smooth. Okay, see an example. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, there is no row of the particles. If you try to cut it, If you try to cut it, what will happen? What you will find? The surface developed is not smooth. Okay, it is a rough surface which is developed after splitting. After splitting with the sharp edge tool, if you split this, try to split this solid with the sharp edge tool like knife, then you will find the surface developed will not be smoother. Okay, they will be rough because of particles, because they don't have any pattern of particles and the surface developed is rough. Again, their melting point is not fixed, and you can say they melt over a range of temperature. They melt over a range of temperature. They melt over a range of temperature. How? Why? Suppose this is a solid and you are trying to melt it. Okay. Suppose the melting start at 927.23. Okay, this region melt at 927.23. This region melt 927.24, 25, 26, 27, 23, 28, like that. So the melting started at 927.23 Kelvin temperature and finished at 927.48, because a different region melt at different temperature. They have a different regions of different packing. Okay, suppose this is region A, this is region B, this is region C, this is A region, this is B region, this is C region, D region, E region, F region, G region, like that. Okay, and all the regions melt at different temperature. So better to say they melt over a range of temperature. Okay, another thing, they have short range order. Short range order means the fixed arrangement can exist in a smaller region, but it is not repeated throughout the solid. A short region can have a fixed arrangement of particles, but that arrangement is not repeated throughout the solid. They are amorphous. Okay, they are amorphous because they have short range order. And the most important thing, they are anisotropic. Okay, another last point, they are isotropic. Why they are isotropic? Okay, why they are isotropic? The simple reason, if you observe this solid from any direction, okay, the arrangement is not fixed, it is a different arrangement. Okay, it is not fixed from any definite direction. And one important thing, the amorphous solids are called pseudo-solid. Okay, because of the tendency to flow. Amorphous solids have tendency to flow. They can flow. Okay,